In this chapter, we will be exploring learning. In the traditional sense, we tend to think of learning as things that we learn in school and things that we read about. But in this chapter, we're going to be exploring learned behaviors, thoughts, and feelings as well. Learning is a relatively permanent change in behavior due to experience. The reason why learning is relatively permanent is because that anything that is learned can be unlearned or changed or modified, which makes it relatively permanent instead of permanent. First, we'll focus on associative learning, where we link two events that occur close together in time, such as Fido here, who starts associating certain things or people with getting a bone. We call that classical conditioning. Conditioning is the process of learning associations between events and behavioral responses. For example, seeing lightning and then hearing thunder. We start to make associations. Classical conditioning is a type of learning where we learn to associate two stimuli and anticipate events. So after repetition, seeing the lightning and hearing the thunder, we may start associating those two stimuli, and we anticipate thunder coming, and we respond by covering our ears to avoid the sound. Learning by association is classical conditioning. Operant conditioning is another type of learning where we associate a response or behavior and its consequences. So operant conditioning is all about what happens after a behavior or after we respond. In operant conditioning, we learn to repeat behaviors that are followed by desirable results. And we also learn to avoid behaviors followed by undesirable results. These concepts of learning come from the school of thought called behaviorism. Behaviorism is the view that psychology should be an objective science, something that we can observe. And behaviorism studies behaviors without taking mental processes into account. Ivan Pavlov can be associated with classical conditioning, as can John Watson. B.F. Skinner is associated with operant conditioning. Let's first take a look at Pavlov. Ivan Pavlov was a Russian physiologist who studied the digestive systems in dogs. He studied this for over 2 decades. In fact, he won the Nobel Prize for Physiology in 1904 for his research and work with the digestion in dogs. As he was working with dogs, he accidentally discovered classical conditioning through his work on salivation with dogs. And he chose to investigate this phenomenon further through experimentation. Let's explore the principles of classical conditioning.
In this video, we'll introduce very basic concepts in classical conditioning by simulating Pavlov's experiments with dogs. Now you may be wondering, if I'm going to be dealing with human beings, why am I looking at a dog? The answer is that the same principles of behaviorism that apply to higher order animals also apply to us humans. So when it comes to classical conditioning, we aren't that much different from Rover here. We're presenting Rover with a stimulus here, a bell. When we ring the bell, there's no response in Rover. That's because dogs, just like human beings, are not naturally wired to have a response to a bell. Without conditioning, there is no response. Therefore, we call the bell a neutral stimulus. I can ring the bell repeatedly with no response from Rover. Next, we'll introduce Rover to a new stimulus, the sight of food and water. Rover's natural response to the sight of food and water is to salivate. He wasn't conditioned to have this reaction. It's natural, innate, or inborn, and automatic, not taught, not conditioned. So this stimulus is called an unconditioned stimulus, and Rover's response is called an unconditioned response. Next, we'll simulate Pavlov's experiment. We'll ring the bell, and then present Rover with food and water. Rover salivates, not because of the bell, which is a neutral stimulus, but because of the food, the unconditioned stimulus. Now we're going to repeat this process. If we repeatedly ring the bell before presenting Rover with food, he'll be conditioned to respond to the bell. Now Rover will salivate upon hearing the bell, even in the absence of food. This response has been conditioned. It's now a conditioned response, and the bell has become a conditioned stimulus. So, to recap, the bell started out as a neutral stimulus. The food was an unconditioned stimulus. When Rover salivated upon seeing the food, it was an unconditioned response. When we repeatedly paired the sound of the bell with the sight of food, Rover was finally conditioned to salivate upon hearing the bell. The bell has now become a conditioned stimulus for Rover, and salivating to the sound of the bell is a conditioned response in Rover.
To recap the elements of classical conditioning, we have a dog and a bell. Before conditioning takes place, the bell is a neutral stimulus. And as you can see, the dog has no salivatory response to that bell. The unconditioned stimulus is the food that yields the unconditioned response, which is the dog salivating. The unconditioned stimulus is a thing, is a stimulus that creates a particular response or behavior. And when it's unconditioned, it doesn't require any conditioning. It doesn't require any learning. It's typically an automatic response. During conditioning, the neutral stimulus, the bell, is paired with the unconditioned stimulus, the food, to yield an unconditioned response, the dog salivating. During conditioning, we repeatedly pair the neutral stimulus and the unconditioned stimulus to reinforce or condition that response. So the bell is rang, the food is presented, the dog salivates, and this takes place over and over and over again until conditioning takes place. When the bell can produce salivation in the dog, we know that conditioning has taken place. Therefore, the neutral stimulus, the bell, becomes the conditioned stimulus, and the unconditioned response of salivation becomes a conditioned response. If the aroma brewing coffee makes your heart race, what is the unconditioned stimulus? What is the conditioned stimulus? What is the conditioned response? In this example, the unconditioned stimulus is the caffeine, which makes your heart race, which is the unconditioned response. When you pair the coffee, the aroma, the sight, whatever it may be, that is a neutral stimulus, because prior to any sort of association, just looking or smelling at coffee alone is not going to make your heart race. But once you start pairing that coffee and that smell with caffeine, which makes your heart race, conditioning can take place. And so that aroma, or the sight of the coffee, becomes a conditioned stimulus that can make your heart race, the conditioned response. Acquisition is the initial learning of the stimulus-response relationship. And the neutral stimulus and unconditioned stimulus are paired more often, the conditioned response becomes stronger. So the more you pair that neutral stimulus and that unconditioned stimulus, that response becomes stronger. So for example, in the coffee example, the more you pair that aroma with the caffeine to have your heart race, the more you pair those two things together, the stronger the conditioned response becomes. So your heart is more likely to beat fast. Extinction is when the diminished conditioned response occurs when an unconditioned stimulus no longer follows the conditioned stimulus. So if you were to stop pairing the aroma of the coffee with the actual coffee that contains caffeine, eventually that conditioned response of your heart racing to just the sight or smell of the coffee may stop, and that's extinction. Spontaneous recovery is when the reappearance occurs when the weakened conditioned response reappears after a pause or after apparent extinction. And this suggests that extinction suppresses the conditioned response rather than actually extinguishes it. Higher order conditioning, or also known as second order conditioning, is a procedure in which the conditioned stimulus in one experience is paired with a different neutral stimulus to create a second conditioned stimulus. Stimulus generalization states that once a response has been conditioned, the tendency to respond in a similar way may occur to stimuli that are similar to the conditioned stimulus. So for example, a dog that is conditioned to salivate at the sound of a dinner bell may also salivate at the sound of a doorbell because these two stimuli are similar. Stimulus discrimination is the learned ability to distinguish between a conditioned stimulus and other similar stimuli that do not signal an unconditioned stimulus. So these are opposites. Generalization and discrimination are opposites. Discrimination involves being able to differentiate between stimuli. Generalization means that you will respond to similar stimuli. Another example of stimulus discrimination is when infants can tell the difference between their mother's voice and the voice of other women. So they may not respond to other women because they can differentiate between their mother's voice and another woman's voice. Applications of classical conditioning. Former drug users can crave a drug when they are in an environment in which they took drugs. They may also associate with people whom they took drugs, and these contexts actually act as conditioned stimuli, and they trigger cravings for the drug. There are certainly physical addictions to drugs. However, there are also psychological addictions to drugs. And one of the pieces of psychological addiction is this learned experience. And classical conditioning can help to explain why some people may relapse because of the associations they made with the drug. So, for example, if an individual is trying to break their addiction to a drug, it actually might be quite dangerous for them to associate with the people that they use drugs with, or to be around a place where they commonly used drugs, or any type of trigger that they associate with using drugs, because that learned behavior, that conditioned response can be so strong that it may incline them to behave in a particular way, and in this example, to crave and maybe even use the drug again. Other applications of classical conditioning include the use of extinction processes or new conditioning that can help change unwanted responses to stimuli. Exposure therapy or systematic desensitization therapy combat psychological disorders using classical conditioning principles. And when we talk about different therapy and treatments for a variety of psychological disorders, we will discuss these behavioral principles and how we use the principles of classical conditioning to treat specifically phobias, anxiety disorders, and other types of learned behaviors as well. John Watson is famous for his study called the Little Albert Experiment. John Watson applied the principles of classical conditioning to humans. He wanted to see if we could condition an emotional response in a human. So he believed that human emotions and behaviors are merely a bundle of conditioned responses, and he called them CERs, or conditioned emotional reactions. Watson and his colleague, Rosalie Raynor, conditioned a baby to associate white rats with a loud noise and fear them. So before conditioning took place, prior to conditioning, John Watson exposed little Albert to a white rat. So the white rat is a neutral stimulus because it did not evoke any fear response in little Albert. So the white rat is the neutral stimulus, and as you can see, no fear was elicited. However, during the conditioning, what John Watson did is he hit a steel bar with a hammer, and it made a very loud noise, and that caused little Albert to cry and be fearful, which is a natural reflex. So that clang, or that big bang sound, was the unconditioned stimulus that resulted in an unconditioned response, which was the fear and the crying. John Watson continued to do this while pairing the two, neutral stimulus, the rat, and the loud noise from the steel bar hitting the hammer. And the natural reflex, again, unconditioned response, was for little Albert to cry and to be fearful. So John Watson did this over and over and over to condition this response in little Albert. And when conditioning took place, all little Albert had to see was that white rat, and he immediately began to cry and be fearful. So after conditioning took place, that neutral stimulus, the white rat, became a conditioned stimulus, and the fear response and the crying became a conditioned response. Watson and Raynor observed that fear, that conditioned response, of white rats also generalized to other white and or furry objects, such as a Santa Claus mask, a rabbit, and a fur coat. So all of these became conditioned stimuli because little Albert generalized to similar stimuli. Think about whether you believe that researchers would be able to conduct the little Albert experiment today. There are certainly several ethical implications involved with Watson's experiment, and I'm not sure that today it would be considered an ethical study. Next, we move on to operant conditioning, or learning through consequences. Edward Thorndike placed cats in a puzzle box with a food reward outside of the box. He would record the amount of time that it took them to figure out how to escape so that they could get to this reward. And he concluded that rewarded behavior is likely to recur, and he called this the law of effect. Thorndike repeated his experiment many times. He also observed that the cats escaped from the box more quickly over successive trials. So the more that these cats were being rewarded and reinforced for their behavior, the more likely they were to escape from the box, the more likely they were to continue this particular behavior. Think about how animals learn new skills. And how does human learning compare with that of Thorndike's cats? Are you motivated by rewards and reinforcements? Do you think that a lot of learning that takes place occurs because we're either reinforced or punished? B.F. Skinner created something that he called the operant chamber, or it's also known as the Skinner box, where he placed a rat into this box or chamber, and there was a food dispenser and an area where the rat could take water. There was a light and a bar and a speaker. And what B.F. Skinner attempted to do was to reinforce the rat for pressing the bar. So every time that the rat pressed the bar, a food pellet would come out of the dispenser. So the food or the water was the reward. B.F. Skinner's rats learned to press this bar, and as a result, they were reinforced with food or water. B.F. Skinner also came up with the idea of discriminative stimuli. So now, not only did Skinner reinforce the rat for pressing the lever with food or water, but he shaped the rat's behavior. And the rat learned that a discriminative stimuli, such as a light, could mold or shape behavior. So B.F. Skinner, in a similar experiment, would reward the rat with food or water, but only when the light was on. So if the light was on and the rat pressed the lever, the food or the water would be dispensed. If the light was not on and the rat pressed the lever, no food and no water was dispensed. What do you think happens? The rat learned to only press the lever when the light was on. Are there discriminative stimuli in our worlds, in our everyday interactions? There certainly are. Think of a stoplight, right? If you see the green, you will go. You know that you will be reinforced because you will get through that light. That's a discriminative stimuli. Think of driving on a highway and seeing a police officer's car parked. Does that make you slow down a little bit? It might. And if so, that's a discriminative stimuli. If you go ask a friend or a loved one for a favor, do you kind of check out their facial expressions, what kind of mood they're in first? That's all discriminative stimuli because it could shape whether or not you ask them for that favor now or later. Shaping behavior is at the heart of operant conditioning. Shaping behavior is used in many different ways to teach, train, modify behaviors. When we shape behaviors, we reward behavior at successive approximations to that desired behavior. Essentially, we set up mini goals to get to a desired behavior. For example, when a child is being potty trained, you may reward that child for just sitting on the potty. And then you may reward that child for pulling off their diaper and then sitting on the potty. And then you may reward that child for actually going in the potty. Those are successive approximations or mini goals to a desired goal. This also allows animal trainers to get animals to perform complex behaviors, and it helps us understand what nonverbal organisms can perceive. When we're talking about operant conditioning, we're talking about reinforcers. A reinforcer is an event that increases the likelihood of a behavior being repeated. Positive reinforcement involves presenting a rewarding stimulus after a response. Try not to think of positive reinforcement as good. Take that out of your mind. Positive does not mean good. Negative does not mean bad. Positive means giving, presenting something. Negative in this sense means just removing something. Negative reinforcement, removing an unpleasant stimulus after a response. So if we go back to the example for positive reinforcement, you see that the child is given an apple for good behavior. The child is presented with something. It is given something. Something is added. That's why it's a positive reinforcement. Negative reinforcement, as I mentioned, is removing an unpleasant stimulus. So the Dairy Queen sign says, "Scream until Dad stops the car." Right? So Dad stops the car, the screaming stops. That screaming is being removed. The next time child screams, what is Dad more likely to do? Pull over the car and get the kids ice cream at Dairy Queen. So in both of these examples, the likelihood of a behavior being repeated is increased. That's what reinforcement does. It increases the chance or the likelihood of a behavior being repeated. And whether that is through the presentation or giving of something or the removal of an unpleasant stimuli, the behavior is still increased. There are different types of reinforcers. Primary reinforcers are naturally reinforcing. Food when you're hungry, water when you're thirsty, taking medication to stop pain. They're typically rooted in our biology. Conditioned or secondary reinforcers are effective through learned association with primary reinforcers. So things like food for doing something, good grades, money. We have to learn the reinforcing value of these reinforcers. So if you have to learn, or if somewhere along the lines you learned that money's a reinforcer, or that eating food after you've already satisfied your biological hunger, that might be a secondary reinforcer. Let's take a look at an example of operant conditioning via the famous sitcom Big Bang Theory.
Well, thank you. How thoughtful. Would you like a chocolate?
Yeah, sure. Thanks. Oh, sorry, Sheldon, I almost sat in your spot.
Did you? I didn't notice. Have a chocolate.
Thank you.
You're here a lot now.
Oh, am I talking too much? I'm sorry. Zip.
Thank you. Chocolate?
Yes, please. Oh. Hey, Kim. Yeah. You know what? Hold on. Let me take this in the hall. You'll never guess who they got to replace you at work.
Okay. I know what you're doing.
Really?
Yes. You're using chocolates as positive reinforcement for what you consider correct behavior.
Very good. Chocolate?
Sheldon, you can't train my girlfriend like a lab rat.
Actually, it turns out I can.
Well, you shouldn't.
There's just no pleasing you, is there, Leonard? You weren't happy with my previous approach to dealing with her, so I decided to employ operant conditioning techniques, building on the works of Thorndike and B.F. Skinner. Yet by this time next week, I believe I can have her jumping out of a pool, balancing a beach ball on her nose.
So far, we've been discussing what we call continuous reinforcement. In continuous reinforcement, the desired response is reinforced every time it occurs. However, in real life, we don't always experience continuous reinforcement, but rather partial or intermittent reinforcement. And this is where responses are sometimes reinforced and sometimes they're not. Think about gambling. Is gambling continuous or partial reinforcement? Partial. Every time that you gamble, you are not going to win. Although that would be very nice, but that is not how gambling works. We follow different schedules of reinforcement. In a fixed ratio schedule, a reinforcer is given after a set number of responses occur. Examples of this might be buy 10 coffee drinks and get the 11th free. Typically, this type of schedule produces very high rates of responding. Variable ratio schedules reinforce behavior after an unpredictable number of responses occurs. So slot machine gambling is a perfect example of this because you do not know how many times you will have to pull that slot machine handle before you will get reinforced. This also produces very high rates of responding and is least resistant to extinction. Fixed interval schedules, interval has to do with time, reinforce first response after a fixed time period occurs. So checking for snail mail, cramming for a test, these are examples of a fixed interval schedule. Another example might be if you're at work and you say to your boss, when can I go on my break? And he goes, after 30 minutes have passed. That's a fixed amount of time. This tends to produce a choppy stop-start pattern of responding. And the last schedule of reinforcement are variable interval schedules. And these schedules reinforce the first response after varying time intervals. So it's again unpredictable, it's variable. And an example here again would be checking for email. Here's another example. Let's say that you go fishing and you're not really sure if it's going to take you 5 minutes or 5 hours before you catch your first fish. So again, it's unpredictable. Really? This schedule produces slow and steady responding. So when it comes to schedules of reinforcement, fixed schedules are set. Variable schedules are unpredictable. Ratio schedules have to do with a number of responses or behaviors. Interval schedules have specific time aspects. Punishment is also something that we discuss in operant conditioning. The intent of punishment is to decrease the frequency of a behavior, whereas reinforcement increases the likelihood of a behavior, punishment decreases the frequency of a behavior. Just like reinforcement, we do have both positive and negative punishment, and again, it doesn't mean that it's good or bad, it just means that something is being presented or added and something is being removed. So in positive punishment, typically someone is administering an aversive stimulus, such as receiving a parking ticket or a spanking. In negative punishment, there's typically the withdrawal of a desirable stimulus, so taking away your driver's license or timeouts. Here's a chart that helps to outline reinforcement and punishment. Reinforcement, again, increases the likelihood of behavior. If a stimulus is presented, it's positive reinforcement. If a stimulus is removed, it is negative reinforcement. In punishment, the likelihood of a behavior is decreased. If a stimulus is presented, then it's positive punishment. And if a stimulus is removed, then it's negative punishment. There are several drawbacks of punishment. Punishment may suppress undesirable behavior, but it doesn't always eliminate it. It also does not teach new behaviors and can have undesirable consequences. Punishment can become abusive and can display inappropriate modeling of behavior. Milder punishments include verbal reprimands, removal of a reinforcer, and a timeout. The last type of learning that we will discuss is called cognitive learning. Processes such as thinking, information processing, problem solving, and mental imaging are all included in cognitive learning. We will specifically discuss insight learning, latent learning, and observational learning. Insight learning involves mentally working through a problem until the sudden realization of a solution occurs, and that is referred to as that aha moment. Wolfgang Kohler studied insight learning with monkeys. He observed monkeys who had bushels of bananas right outside of their environment, and he observed them use various tools and objects that were within their environment to get to the bananas that were outside of the environment. And he noticed that these monkeys must have been taking in their environment, looking at what they were exposed to, and mentally worked through problem solving and how they could get to those bananas. Latent learning is learning that occurs without the apparent reinforcement and that's not displayed until reinforcement is provided. Cognitive maps are a prime example of how we experience latent learning. Cognitive maps are mental maps that we have of places that we've been, or places that we currently inhabit. For example, if a friend calls you and they ask you, how do I get to your house? And if you can give them directions and street signs and landmarks, you've built a cognitive map that you rely upon as you're attempting to give directions. Maybe someone goes to the grocery store and they call you to ask where something's located, and you pull up that cognitive map that you've created from visiting that grocery store before, and you can direct them to where they can find that item. Or even as you're listening to music and you can recall a song and the words that you may not have even realized or made intentional effort to remember, That's all latent learning. Latent learning, again, is learning that becomes apparent only when there is an incentive to demonstrate it. And a cognitive map is a mental representation of the physical features in the environment. The third type of cognitive learning is called observational learning, which is learning by observing and imitating the behavior of others. Think about maybe what you have learned via observational learning by watching others and then imitating that behavior. Albert Bandura is famous for the Bobo doll experiment, where he had children watch adults act aggressively towards this Bobo doll. And then he allowed these children into the room with the Bobo doll. And what he observed is that those children who watched the adult act very aggressively toward the Bobo doll also imitated that behavior. This led to a host of research about observational learning and modeling, and how, if children watch aggressive behaviors, will they also imitate those behaviors? We call this the violence viewing effect. Violence is committed by attractive perpetrators, and if that is the case, then individuals are more likely to imitate that behavior. If most of the violence is unpunished and the victim's pain is not portrayed, then the individual is more likely to act violently. If many of the incidents involve justified violence, then that individual is more likely to engage in that violent behavior. Through desensitization, becoming less sensitive to, children become indifferent to violence, and even the very young imitate what they see on TV.